I was in the back furiously trying to get better imagery into our deck, and then realized that we submitted the PowerPoints ahead of time. So there was no saving our images. So apologies in advance. But we're here today to talk about failing to scale, or essentially the bumps in the road that we hit as we've scaled our cloud presence there at HashiCorp. So bumps in the road while we're scaling cloud access. For those that haven't met me before, I'm Bengtson. I'm the Senior Director of Security Engineering at HashiCorp. I've been there about 4 years now. I think in a week and a half will be my official 4-year mark. I've previously worked at Capital One, Netflix, small startups, but I've been in the cloud space for many, many years now. And I'm privileged to be here with a colleague of mine, Devon.
Hey everyone, my name is Devon Powley. I'm managing the cloud infrastructure and platform security team at HashiCorp. I've been at HashiCorp 2.5, almost 3 years now. And before that was at Capital One.
And so we thought we'd start with a quick background of HashiCorp. Just for the folks in the room, show of hands, who's heard of HashiCorp before? Awesome, quite a few hands. For those that didn't raise your hands, have you heard of Terraform? There's a lot of people that don't realize that Terraform is actually HashiCorp, which I think is a really great thing for us. And people recognize the products that we build and use. But let's dig into a little bit more of what HashiCorp offers real quick, just to show what we're actually offering and why we've approached things the way we have. So we focus in infrastructure, networking, security, and application space. Terraform is probably our most popular product. With Packer, I'm sure for those here with cloud security might have used as well, building immutable images. Vault is probably one that you've also heard of, securing your secrets, and we'll talk a little bit more about dynamic secrets in cloud here a little bit later. But we also offer Consoles, our service mesh, kind of service discovery solution, boundary privilege access management to databases and servers, Nomad or container runtime. Waypoint is kind of think of internal platform, if you will, for your developers. And Vagrant, actually the first product of HashiCorp, built while our co-founders, Mitchell and Armand, were in college. Funny enough, that kind of tells you how smart those guys are. Let's start with a timeline of where we came from to where we are today. I joined in 2019, but prior to that, we primarily focused in open source software and self-hosted enterprise. Terraform was an OSS product. It was coming into Terraform Enterprise, so you could manage Terraform at scale within your company. And we were expanding into the cloud. In 2019, Terraform Cloud was announced. And as you can see, we started with a small AWS presence. We're growing a little bit. I joined in November of that year. When I joined, we were at 40 AWS accounts. And today we're going to walk you through the bumps as we grew to 20,000 plus AWS accounts. And as you can see here, we've expanded our presence in other cloud providers as well. So 2020, we announced the HashiCorp Cloud Platform, primarily on AWS, with Vault and Console being our first 2 product offerings. We realize our products can be difficult to run and operate. Any operators in the room of Vault, any Vault admins keeping the systems online, can be a difficult thing. And so one of the things we wanted to do was build out a cloud platform that our customers can trust. We'll take the difficult things of operating Vault for you and let you actually focus on deploying the secrets and managing things and making your application logic better. And fast forward to today, we're in AWS, Azure as well, and in the future, likely more cloud providers as you could expect as you expand. So when you think about expanding, I mentioned we went from 40 accounts to today we're over 20,000. One of the things we wanted to do is really isolate customers, make it so that you could trust that we manage your services that are critical to the success of your company. And so we needed to go from very few accounts to many, many accounts. So how do you do that today? We think about scaling in 4 different areas: scaling accounts, identity, infrastructure, and costs. I'm going to focus on accounts and then hand it off to Devon to take you through the rest. But when you think about accounts in AWS as our primary focus area today, we're going to scale beyond the 40 to the 20,000 plus. The first problem that you hit is kind of managing the root account access and creating accounts. Anyone here in the audience creating accounts manually still today? I'm sure there still are some. I do it personally. if you think about getting to the 20,000, obviously that's not going to scale. I wish I could clone Devon 20,000 times and say, hey, go click the buttons for me. But also you hit some bumps when you're in AWS as well. So AWS organizations are a great concept that came out, I think in 2017 was when they first came out. Gave you a better way for creating accounts and managing them, organizing them across the different organizational units that your business unit might have or different environments. There's a 5,000 account hard limit that exists in the organization today. And so if you think about scaling beyond 5,000, that means you're going to be managing multiple organizations. Lots of fun organization concepts that AWS provides to make things easier, like CloudTrail and things. But when you go beyond organization, multiple or a single organization, you have to figure out how do you manage that as well. Providing a service for our customers, we needed to make sure that if our environment happened to have some hiccups, that we get the support from AWS that we want. There's no API to actually enable enterprise support. You would hope that you could click a button in your organization and say any account under this should have the same support level that our enterprise organization master payer has. But unfortunately, that's not a thing today. So as you create new accounts, you have to automate how do you enable support. So we actually have scripts that as we create new accounts, will batch requests to AWS. Hey, please enable enterprise support on these new accounts that we've created. And then how do you check that that actually got done? Are you going to have someone looking at your support cases, responding to email? There's no real API to actually see what your current account support is, but there is an API that you can cheat with. I think it's describe severity levels. And if you run that in an account and you can, if you see urgent or critical, that can tell you that, hey, your account support actually did get adjusted. So as we were building this account factory for use for our cloud platform, we had to think about these problems that we want. Like what happens if we have an issue, but we have an account that we didn't upgrade to enterprise support? It's not just a phone call to Amazon to say, hey, please do this for us. So we had to think ahead. And then root accounts, you can't use the same email across accounts. Some people like to do the plus trick on emails, especially with G Suite. You could have like W Bengtson plus CloudSecNext SANS. So if I start getting emails from Hermetic or something, I know that my email was shared. Can't do that too well. If you think about not every team needs access to all the emails. You need to be able to manage who might have access to the support email versus not. And so we went a Google group route. So that works well. AWS sends, if you don't manage alternate contexts, AWS sends everything to the root account. So you get abuse cases, support is, if you don't copy yourself on support cases, you're only going to get correspondence in the console or the root email. Billing emails, password resets. So we had to manage that. As I mentioned, that worked well until we hit about 2,500 accounts or so, probably much less because we'll get into that in a bit. But at the time, Google only let you be a member of 2,500 Google groups at once. And so there's a period of time where I just wasn't being added to new groups at all. And it was just kind of like, what happened to our automation? Did it break? And we hit this limit. I think now it's 7,500. Devon looked up the other day. But we had to basically build a root email forwarder. Think like re-implementing mailing lists via AWS SES. And that manages our root accounts today for us. So I can assign every root account forward to the SecOps team. For the account owners that own HashiCorp Cloud Platform, they can also be copied on root account emails so that they can understand where support cases are being copied to. And for the individual teams that have their own infrastructure, they can also be on the root account. So they are aware of what is going on in their account. And then, of course, with root accounts, you have to protect those roots. So how do you do that at scale? Is anyone putting MFA on every root account in their environment today? A couple show of hands. Is anyone using an SCP to disable root altogether? That hand shot up fast. I love it. Anyone using YubiKeys for root accounts? A couple hands in the back. So we are also a remote company. That's one thing I forgot to mention. And so using a YubiKey or something like that is out of the question for us. Because we'd be like, hey, Will, could you FedEx that YubiKey overnight to me so I can get in this account. And so we've chosen to really protect our management account and then SCP the root account off completely so that we're rest assured that even if you get a password reset email, not going to happen. We'd have visibility into that password reset happening, but also the root account just doesn't work at all. And for those that aren't aware, there's really no need to use root outside of if you've locked yourself out of an S3 bucket because you've been managing bucket resources or a resource policy, or you want to really close the account. There's really not much use for root, so just SCP that bad boy away, and off you go. But those are some of the problems that we were hitting early on as we decided to scale, and many, many more bumps in the road, as Devon will get into here with identity.
Awesome. Thanks, Will. Yeah, so I'm going to talk about scaling identity and bumps we hit there. As we talk about the different options we pursued, just note that the point of this talk is not necessarily to endorse an option for your organization, but just for you to be aware of some road bumps that we hit so that you hopefully get to avoid those. So the question is, how do we provide least privileged access at scale? The next question then is, which access model do we use? So you could go with hub and spoke. Think of a bike wheel where you have a hub account, that's your central identity account that you federate into, and then spoke accounts that you can then assume into from there. Or you could go direct federation and just federate into your target accounts directly. With the hub and spoke model, Segment released a blog post, I think about 5 years ago, that kind of walked through how they made the hub and spoke model successful for them. But it's harder for us. We wanted to eventually get to a point where we're least privileged, where you're requesting access to a single account and a single access level at a single time. And the hub and spoke model is more set up for job profiles. So you have a role in the hub account that's tied to a job profile. Let's say you're a cloud platform engineer, and you can then federate into that role in the hub account, which then has access to the cloud platform accounts. So you have all of the access that you would need for your job profile at once. So harder to do least privilege there. And then you're also role chaining. So this one's a sneaky limit that AWS has, but role chaining, you start in the hub account, that's your first session, then you assume into the spoke account, that's your second session. On all subsequent sessions, so on the second session and beyond, you're limited to 1 hour. In some cases, this is considered a security feature, right? You don't want folks with long-lived credentials to your production environments. But HashiCorp's a developer-first company where we have lots of sandbox and development use cases where it's not pragmatic to ask developers to refresh their creds every hour for development or for sandbox cases. So we ultimately went the direct federation route. This one's easier to scale for least privilege. As I said, you can request access to just a single access level and account at a single time. And it's easier to audit. You're not auditing both where you can federate and then where your federated session can then assume. You're just auditing where you can federate. But perhaps the most important factor at play is, what did your boss use at his previous company? So we'll use direct or set up direct federation at Netflix. It worked really well, and brought that experience over to HashiCorp. Talking a little bit about authorization, regardless of whether you're going to hub and spoke or direct federation, you need to set up. You're basically doing authorization based on group membership. That group membership could be in Okta, it could be in Google. We talked about Google, and that's where we ultimately went. And those groups, you set up a group per account and access level. So if I want admin access to X account, there's a group that corresponds to that. Then as an organization, you have to figure out, okay, what are our job roles? What levels of access do we want it to offer in each account? Let's say we have 4 levels of access times 20,000 plus accounts. That's 80,000 plus Google groups. You throw in the 20,000 root emails. That's a lot of Google groups, which Google in and of itself, there's no hard or no limit that low, at least on Google groups. But when you're using Google groups at scale like that, we ran into a lot of rate limiting. We had to build out a cache for Google group memberships. We weren't the only stakeholders of Google Groups. In fact, we were just using it for cloud access, but the main stakeholders were our IT team managing the Google Workspace. And they had a lot of degraded performance especially when they were syncing groups from Google to other systems. So another thing to keep in mind. And then we had to answer the question of how do you ensure the folks that need access immediately can get it in the event of, let's say, an operational incident or a security incident. The easy approach to that is just give them access by default. Let's say give your SecOps team access to the security audit role in all accounts. That way, when a security incident comes along, they can log into the account immediately and start triaging. Well, one, that's not least privilege. That's not that model that we want to get to, where you're just requesting access to a single account at a single time. But you also hit those Google group membership limits that Will talked about with the root email. You can only be a member of, at the time it was 2,500 Google groups, which scales to less than 2,500 or less accounts. So that doesn't scale. What we ended up doing was pivoting away from that access by default once we hit these limits, and built a custom solution where you can self-service access requests. It has auto approval and approval flows. So let's say the security teams auto approve for the security audit role. So they don't automatically have the access, but they can automatically get the access. And let's say MFA when they make that access request. And then the approval flows allow us, we were moving from a process where IT would hand out AWS access based on tickets that you submit to them. We were finding that IT is not best positioned, especially at scale, to tell you who's should be in your AWS account. That's better left to the account owner. So we instead built a system that routed the access request to the account owner for approval. And then lastly, we were finding that the longer you were at the company, the more access you had. I think this is probably a pretty common problem. And we wanted to figure out, okay, outside of user access reviews and just manually dropping access, is there a way we can build this construct of ephemeral membership? Google doesn't have this natively, so we ended up having to build that into this custom solution. So now once you have the access, you have access to an account and an access level. Let's say you have admin access to an account. How do you get credentials and console sessions? When we were at 40 accounts, we had IN users, user auth for human access, which goes against both of these requirements. Static credentials, likely stored in a variety of different places. And then you're also, to log into the console, you're not going through SSO, you have a username password tied to those users. So we wanted to eliminate static credentials where possible, and then also implement Okta SSO, which is Okta is our IDP for human access. The tooling back then was rather limited. AWS SSO, now called Identity Center, was the AWS native choice. With that said, at that point, and for a long time actually afterwards, there was no public API to automate this. So that's a non-starter. If you're building out 20,000 plus accounts, you need to automate everything. The natural choice, and this is a choice that would work well for a lot of organizations, is a direct integration with your IDP. So for us, it was an AWS Okta integration. With access by default, I mentioned that we went down that path initially. You're going to hit SAML assertion limits because the SAML payload has all of the access that you have to AWS. So let's say you have access to thousands of accounts. When you go and make that SAML assertion to sign in, you're hitting that SAML limit. But we moved away from access by default, so that wasn't prohibitive. The prohibitive factor was, at the time, we actually had Okta as our IDP, but we had Google Auth primary. So we would sign into Okta through Google. We've since changed that, but basically what that means is Okta doesn't know what your SSO password is. On the surface, that doesn't really stick out as a huge limiting factor, but a lot of the tools that have been released in the ecosystem around vending credentials for AWS through Okta require that Okta knows about your password, so they wouldn't work for vending credentials. So the question was, do we go back to using IAM users and get rid of this scaling project altogether? Or does Will go build a custom solution overnight? So we ended up building a custom solution that integrates with HashiCorp Vault for vending credentials, but that manages and checks entitlements. So that basically your group memberships in this case. It vends STS credentials, so we're away from those static IAM users. It vends it to humans and systems actually. So for another time, but you can essentially exchange a GitHub Actions JWT or a Terraform Cloud JWT for temporary credentials, similar to how dynamic credentials work for both of those. And then you still have to take into account those session duration limits. So we had to use an IAM user as the source of federation instead of a role, because otherwise we're still hitting that 1 hour max session duration. And then this custom solution provides console access. Now there's other tools in the ecosystem that are offered that do these things out of the box. ConsoleMe from Netflix was open sourced a few years ago, I think after reInvent. If you put two and two together, Will was at Netflix, ConsoleMe was open source. You can see where the inspiration for our custom tooling came from. But then Leap is another great tool for getting into the console and vending credentials at scale. Next is scaling infrastructure. So with infrastructure, with 20,000 plus accounts, you have to manage infrastructure in all those accounts. At the very least, you need to manage the IAM roles that are used for federation and the policies that are attached to them. Some people use config widely or put S3 buckets in all accounts, but at the very least, there's some set of infrastructure that you need to manage as code so that you can make updates. Let's say if you want to change the permissions that are attached to your roles for federation. So us being a HashiCorp shop, we are strongly biased towards Terraform. Our initial inclination would be, let's use Terraform OSS to do this. That's what Terraform is built for. Has anyone raised hands? Has anyone run into limitations with scaling Terraform? All right.
No hands were raised. Let the video show.
For the record, no hand. No. But basically, what happens is with Terraform, each provider takes up a certain amount of memory and CPU. So a provider in the AWS context is a region account combination. And if you have 20,000 accounts, let's say 17 regions, I'll let you do the math, but that's a lot of providers. And that's a lot of memory and CPU that you have to scale for. You can theoretically scale for that. Is it cost effective? I mean, I think that's up to you and your organization. But we moved away from that. And then also Terraform also, the amount of time it takes for a plan to run is very resource dependent. So if you have, let's say, 4 roles and then 4 policies, that's 8 resources across 20,000 accounts. That's a lot of resources that Terraform has to describe the state of. And that takes a while for the Terraform plan and apply to execute. So Terraform OSS unfortunately didn't work in this case. We tried Terraform Cloud, which basically can we get around the CPU memory limits by just segmenting our Terraform resources out into a bunch of workspaces. Theoretically possible. You need to build something that orchestrates on top of Terraform to manage all those workspaces, or on top of TFC to manage all those workspaces. But it still doesn't really help the time constraints of you're still having to describe 20,000 plus resources and get the current state from the cloud provider. Then obviously we're not going to get into a Terraform versus CloudFormation debate, but CloudFormation is another option. It's the AWS native option. Stack sets is a great feature for allowing you to do this at scale, especially if you're in a single organization. Will mentioned earlier the 5,000 account limit. So 20,000 accounts is at least 4 AWS organizations, right? And we'll give you stats on what we currently have today. And if you're really fancy, you could theoretically manage your CloudFormation stack sets with Terraform. But what we ended up doing was building internal tooling where you have a basically custom worker that's executing against a set of APIs in AWS to perform work. So let's say it's creating and updating an IAM role. And we have a system that basically fans this out based on messages to queues, SQS queues, and then Lambdas receiving messages off of those queues and doing this in parallel. So it works. There's an open source project that was announced earlier this year called Starfleet that is essentially what we do out of the box. Starfleet was authored by Mike Grima, who worked with Will at Netflix. So again, you can see the trend of the Netflix inspiration helping other companies down the road. And then lastly, we have scaling costs. So the ideal solution or the ideal scenario is costs don't scale with the number of accounts, and they shouldn't for the most part. But there were a few pitfalls that we ran into here as well, specifically around guard duty and config. Guard duty conflicts with our CSPM tool. So the guard duty pricing model is based on the number of CloudTrail events. Our CSPM tool polls our AWS accounts every so often. I think right now we have it at a 30-minute cadence. If you are doing that in one account, let's say to describe the instances, maybe you have to paginate, but that's essentially one set of describe instances calls. If you're doing that in 20,000 plus accounts, that's 20,000 calls, which is a lot more, or is many more CloudTrail events, which increases the guard duty cost. We actually went from a single AWS account for our sales team, which was used for demos of a variety of our products, and we had trouble with resource attribution. We could do a whole talk on resource attribution, but what we ended up doing was splitting that account out and giving everyone their own dedicated AWS account for demos. And they would be demoing our products, maybe not in the most secure way, maybe going through a tutorial that's not ready for production hardening, but more for showing us a high level how to use our product, or customers a high level of how to use our product. That's an important environment for guard duty to be on, and because that's going to be catching quite a few things. So we saw that we have about 600 sandbox accounts, and just at that scale of going 1 to 600, the guard duty costs really ballooned there. And then config is an important one to note here. More just if you make a mistake with config at a scale of 20,000 accounts, it can be costly. So one mistake I made was we were changing the number or which resources we were tracking in our config recorder. And I made the mistake of tracking IAM resources across all regions. IAM's a global service, so no need to track across all regions. But when I did that, let's say that there's 50 IAM roles and then 100 AWS managed policies in the account. It's tracking all of those resources across 20,000 accounts, and then you're basically inflating your costs of doing that by 17 for the number of regions. So it gets costly. And then when you update a config recorder, we also there's the caveat of if you delete it and then recreate it, AWS goes and scans all of your resources again and charges you for that. So make sure you're updating and not recreating. Otherwise, that gets costly at scale. So Will's always asking me for metrics on my team and what we're doing. So I'm going to toss it back to Will to give you metrics on where we stand today.
Awesome. Thanks, Devon. So yeah, as you have seen, we hit some bumps there was light at the end of the tunnel. We have come out successfully on the other end. If we were to do it today, there's a lot of learnings that we've had, and we do things a little differently. But hopefully you'll avoid some of those now with some tidbits. If you are going down the path of scaling with Terraform, let's chat. We've learned a lot on how to break out your Terraform resources and configurations. And essentially that's where we are today. We've redone some things. We're at 23,000 plus AWS accounts today. I think it's something like 14 or 15 AWS organizations that we manage, all via Terraform and our custom tooling. We've reduced our IAM users to 80% from when we started back in 2019 with 40 accounts. No human access for IAM users. The IAM users we have left are service accounts, as we call them. IAM users that we put into Vault to vend different roles or into other third-party systems that can't natively assume into our environments for access. And most importantly, zero access by default. And as we mentioned, we hit the bumps of scaling via Google Groups, trying to figure out tooling with Okta and the CLI, Terraform management, and how wanting to expand from just managing IAM roles to managing resources, ballooned our Terraform Enterprise and essentially crashed it. But we're here all day, and tomorrow we want to thank you for coming out and listening to us today. I think we've got like 3 minutes left in our session time to take questions, but happy to take questions on Slack as well as throughout the day today and tomorrow. But thank you all.